Yeah, I think it has started recording now. So welcome everyone, all of you. We're gonna talk about the first sub skill in the skill of problem solving. This is one of 7 skills we'll be covering in total for the problem solving skill. This is the first one. The other ones are relatively shorter, but this one will take us all of today. So perhaps I should start sharing the screen now. Those who are online. Yeah, looks good. And then so we've done most of the easy questions now, the first 15 minutes. Perhaps we can do some of the medium problems. So as usual, I'll give you 60 seconds to think about this, try to figure out the solution. You can try to solve this. Doesn't look too difficult. So the International Space Station is it's a big spacecraft. I wouldn't expect it to go at 856 miles per hour. That'll be too slow, right? Probably you don't need math to know the answer. You just need to convert from miles per second to miles per hour. So how does this work? Well, you need to know how many seconds are in 1 hour. Hi. Are you here for the SAT math? Are you here for the SAT math?
Just wasn't to see.
Oh, okay. First. That's more people than we usually get. So how many seconds do we have in 1 hour?
It's a
good question to ask.
It was like the International Space Station. Oh,
60 times 60, right? 60 times 60. Then probably we should take this 4.76 miles per second. And we should multiply by 60 times 60. It's slow. 4.76 times 6. Yeah, it does look like the first one. As I said, it doesn't really make sense if you choose any of the other two. Because the spacecraft is good for high speed. So that's not too difficult, I hope. Then we have the next question. Maybe you can try to do this one as well.
فاكر
I'll start writing down some stuff.
اللي جايب 201
1990, we had 2.5 people per square kilometer. 2.5 people, just take a person and you cut them into half, and you have 2.5 people. You guys are supposed to laugh at this. Then in 2014, you have 3.3 people per kilometer squared. So maybe I'll say it again. You take a person, you cut them into 10 pieces, and you just take 3. Now, at the time period, the land and the land stays as it is. The space of it is 100,000 people, 100,250 kilometers squared. And I always put great emphasis on the units because I think units can always hint out at something that you can figure out. So here you have kilometers squared, just normally, and here you have them being divided. So even if you don't understand the problem, you don't know what to do. If you just divide by the kilometer squared, you divide something by the kilometer squared, maybe the number of people, you'll get people per kilometer squared. So if we divide, so here's what I mean. If we divide this, so this is dividing the number of people, which I'll color, let's say in green. The number of people, this is what we need to find. And this will give us something which says P per kilometer squared. So just by following the units, hi, how's it going? You are able to make some good progress on the problem. And the good thing is that this is true. So I can use this fact twice. I'll literally copy it as it is. And I will just plug in the values. So here, one time I had 2.5 people per kilometer squared. It gives me the number of people. So that's an equation in one variable, which is the hashtag. Variable hashtag. It's a very funny name for a variable, but it is one. Then I should probably, to find this number of people in 1990, I should probably multiply 2.5 people per kilometer squared by the number of kilometers squared that we had in Iceland, I think it was. Then the units cancel out. We get something in people, so that's the number of people. 2.5 times 100,250. You get 250,625 people. Okay, I'm glad we didn't get any halves in there. And we can actually apply this one more time. So this is the number of people in 1990. Because I used the ratio from 1990. But I can use the exact same idea for the case of 2014. So I would do like this. Here I would write 3.3, I think it was. Yes, 3.3. And then I proceed in the exact same way that I did. So if I want to find the number of people, the hashtag, then this would be equal to this times that. It's just, multiplying both sides by 100,000, 250. The units cancel out again, and I get something in P, which is 3.3 times 100,250. I plug this in. Get 330,825. Yeah, but then the question is not asking us for these. It's asking us for the increase in population. So the answer would just be the difference between these two. So this minus, you can write it as it is. So you could write 2.5 times 100,250. So you get this answer. And then we're done. I hope this is not too much for you. If you have questions, you can always ask, of course. So just to recap, just focus on the units. If you write everything clearly using the units, then it's done. It's easy work. Like I remember myself, I had some physics exams in my academic career, which I had no idea what was going on, like absolutely no idea. And I would have choices piled up, let's say kilometer per hour. All of them were kilometer per hour. Then probably I should define the thing that has kilometers by the thing that has hours. Of course, this is a simplified version of whatever I had in this exam. It was a horrible exam. I don't want to remember it. I think that's enough. So that's a good lesson for you. And you can also get some time to think about this problem. With this problem, I don't think you can guess the right answer. It's not 25%. 7. It's very bold of you. Say 7. Don't get me wrong. I hope you get all the answers correctly on the exam, but that's not the way. You need to try something else. Thank you. Yeah. $60. Who's counting? 0.555 ounce per inch. Yeah. And the online company sells, so this is the density of the beeswax. And the beeswax itself has a price of $8 per, maybe I should write $8. Yeah, $8 per ounce. And we want to find the selling price. Selling price will be in dollars per, not inch, but cubic inch. Oh no, this is also cubic inch. I misread it. This is ounce per inch cubed, and this is $8 per ounce. And I want to get something in dollars per inch cubed. Then here's how I can get this. I'll make a proper simplification here. So this is a bit non-standard, but I hope you don't mind if I just literally write the units upside down. Usually we write them next to each other, but if I write them upside down, you'll see what I mean. Mathematically, it is precise to say this. It's just non-standard. We're not used to it. Okay. Maybe I'll put them next to each other. If I have something ounce per inch cubed and dollars per ounce. Well, what if I multiply these two things together? Then I'll probably get something that is in dollars per inch cubed. So that is what I mean when I say follow the units. So what this is telling you basically is if you just multiply this thing by that thing, just by following the units, you should be able to get the answer. The answer should be 8 times 0.555. Which is 4.44. Now, I have not done any reasoning about this. I've not done any convincing. This is a word problem, but still, I solve it like I have not even read it. Let's see why this makes sense. So the price is $8 per ounce, and for each ounce, for each ounce you have 0.555 cubic inches. So this is really how you say it. Let me repeat this again. So the price is $8 per ounce, and each ounce is 0.555 cubic inches.
.55 ounces per cubic inch.
Then it's the opposite. Yes. Then it's yeah, okay. Yes, because I thought about this for a moment and I was like, okay, this doesn't make sense because then it would cost more, not less than 8. But then yes, if you say this, then you have $8 per ounce, and each cubic inch gives you half an ounce, well, almost half an ounce. And so if you want to look at the price per inch, I mean, if we assume this is 0.5, then it should be a half. I mean, close to. And mathematically, if you want to make this very precise, you multiply the two terms, and you get the result. Is this clear?
That's the correct answer.
That's the correct answer. We were able to verify it by following the units, because we want so here's the thing. We want the answer to be in dollars per cubic inch. You see? I don't even need to read the problem and make sense of it and then think, oh, okay, beeswax, and then densities, and then the ounces, and then that. If I just write down the units and I make the right multiplication, so I want something in dollars per inch cubed. If I multiply this unit by that unit, I'll get something in dollars per inch cubed, which is what we have here. So this is demonstrated by this fact. The units can be treated as fractions. They are values in the sense. And if you treat them as such, you will be able to get new units and so on and so forth. So we do this, we figure out, okay, we probably should multiply these two. And then if we multiply these two, then we should multiply these two. And then we do that. That gives us the answer. We'll do more of these, and I think it will be more clear. So again, some story about some guy called Paul Revere. I don't know. Sounds French. I don't know who this guy is. Do you know who this guy is?
Paul Revere.
I don't know.
Yeah, some American Revolution stuff. Yeah, Don't worry about it.
Is he like a big thing?
Yeah, he's the one that signaled that the British were arriving in America.
Ooh, that's crazy.
Yeah.
Because I think once they got to announced the independence, they were like, the British were like, "Hey, we're gonna put you back in order," and then they sent everyone.
Yeah. He was the one. So that's the whole story. It doesn't really matter, but
You're from US.
yeah.
That's cool. Wow! Shout out to Paul Revere. You know? Big man. Okay, so there's some story, but I mean the stories are always distracting. And if you just write down the inputs that you're getting, and then you'll be able to reach the answer without knowing much about the problem itself. Who's going from Charlestown to Lexington? If he had went without stopping, he would have traveled 11 miles in 60 minutes, 26 minutes. So 11 miles each, 26 minutes is his speed. 11 miles in 26 minutes. Like if you say how many threes are inside of 6, it's the same logic. I hope it's not too difficult. Then he's asking what the average speed would be. But then the trick here is that we need the speed to be in what unit? Miles per hour. Yes, so we don't need it in miles per minute. Yeah. But you first, of course, you need to be able to say, hey, this is 11 miles per 26 minutes. And then I want to bring it to something that has miles per hour. And the way to do this is to ask yourself, how many minutes are in 1 hour? Last time I checked, it was 60. Right? And it's funny because minutes is just like a variable. You just treat it as a variable. So minutes is just 1/60 of hour. I mean, I know this makes perfect sense, but just deal with this abstract nonsense for just a little bit. Okay. So this looks interesting. And this is the piece of info that I have right now, the one that is in this box. I want to remove minutes and place in hour. So I do exactly that. Right, 11 miles per 26. Well, instead of minutes, maybe I'll color it in, I don't know, green. I will put 1/60 of hour. So I'll literally copy this, remove this, and put that. And then I have something in hour. But it's a bit confusing to write it like this. So I would recommend that you write it in terms of a fraction. So if we start from the very beginning like this, the following expression, then we can write 11 miles divided by 26 minutes. And then we have 11 miles again. And still we have 26. Instead of minutes, we write 1/60 of hour. And let me separate the units and the constants. So the constants will be here. Here I'll have miles on top. and hour on the bottom. You have 26 times 1/60, and on top you have 11. That's the answer. Don't need to make much sense of this. Just need to look at the units, make the right substitutions, and then we're good. So you want to calculate this, for example. 11 divided by 26 times 1/60. 25.384. The nearest tenth. So 25.384. How would you round this to the nearest tenth?
Like 4.
25.4. Because you could do all of this, and you don't know how exactly you would like to round nearest tenth, and then you lose the points and you lose the time because you spend this time and it didn't give you the intended outcome.
On the task, should I like explain these questions?
No, so you just give the question as a numerical value. Have you taken the SAT? Ready? Okay, so you have the exam in
7th of like next month.
yeah 7th of November. Yeah, we'll be done by the 4th. The remaining skills. So maybe afterwards we'll organize some sessions to do some mock exams and all of that. That would be nice. But in general, so the SAT used to be only multiple choice, and now they have something like a short answer type of question. So you would have, let's say, a box like this one. You'd write 25.4 as your answer. So, but you don't need to explain anything.
Okay.
You just put it out of the sky. I think Ali said 7. He's unlucky, but let's say he gets it from the first time. What are the odds? But if he does, then he just gets the full points. Okay, maybe we scale things up a little bit. We can do some hard problems. So this one is really annoying. I think I tried to do it for the first time and I was stuck. Not because it's a hard problem. It's just because the language is so confusing. So as usual, you have 50 seconds to tackle this. Hi, Abu Bakir. Do you hear us?
Yes, I can.
Okay, so we're doing the question now. We have 60. Well, right now we have 30 seconds to think about the question. I hope you're following.
Oh, okay.
Yeah, and if you want to participate, just unmute yourself.
Mhm.
All right. 10 seconds more. The language can be very confusing. Let me show you how. So there is a way to calculate the approximate age in years. So the goal is to approximate the age in years. And remember, this is all about units, and I really emphasize it. It's just about units. We want to approximate something in years. So what do? We multiply the diameter of the tree in inches. So maybe I'll write the diameter of the tree in inches, so it's dt inches by just a constant. What's the constant? Is there's something called the growth factor. Maybe we'll call it G. GF, for growth factor. This gives us the age of the tree. So it is very important to be able to write this down. Now this is just a constant. So like a constant or just a scaling factor does not have any unit. It's also important to understand. Now let's take a look at what the question is asking us to do. It's asking about the white birch tree and a pin oak tree. So the first thing I'll do without even thinking is I'll box these two. So everything else is useless. This is what we care about. Then I want to utilize this, I don't want to say equation, but maybe I would say this machine to be able to retrieve the values that we want. But how would you do this? We want to find the difference in diameters in inches. So we want to find the, maybe I'll call it the WB for the diameter of the white birch. And we want to find the difference between this and the diameter of the pin oak. I hope you see where this is going. So perhaps it is a good idea to find this thing first, and then find that thing afterwards. Then we can compute the difference. Maybe I'll write the full equation. So this was dt times the growth factor. So the growth factor for the white birch is, I'll write down, right? Growth factor, white birch. And there's also the growth factor for the pin oak. Let's see. There is a fact that we still have not utilized, and that is the difference in 10 years. So we want to know what the diameter would be when they are 10 years old each. So this is in years, it's 10 years. 10 years. For both of them. So I hope I'm not going too fast. Okay. But then, what's the growth rate of the white birch? 5. And what's the growth rate of the pin oak?
30.
Okay, so I have an equation in one variable, which I can solve for white birch, and also the same thing for pin oak. Then I just write down. So if I just divide by 10 divided by 5, so I get that EW will be equal to 2, but 2 of what is a good question to ask. Feet or inches? Well, let's see. This formula multiplies the diameter of the tree in inches by a constant. So the diameter of the tree in inches. Then this is in inches. and that is in inches. That's really what's given to us here. We're multiplying the diameter of the 3 inches. So if we do it now, we multiply 2 inches by a growth factor of 5 to get 10 years. Is this good? And you multiply, well, how many inches? Let's see, for the pine oak, the pin oak. It's 10/3, right? 10/3 inches is diameter of the pin oak. This is, of course, also in inches. Then here's what I do. I just subtract the two values. So 10/5 minus 10/3. 10/5 is 2, and 10/3 is just 10/3. Maybe I should write this as 10. So I write this as 6/3. Then I have minus 4/3. But it's fine. The difference should be positive. Okay, what's 4/3 or minus 4/3? It's 1.333333. Then probably this should be the answer. Take a moment to think about this. I know that this fact can be a bit distracting. Can be very distracting. That the diameter is 1 foot. I think it just means that they are on par with each other. So they start from the same point. What I did at the start was I was like, okay, the growth factor is 5. Okay, then 5 times well, 1 foot is 12 inches, so 5 times 12, 60. 3 times 12 is 36. So I just take away this. I take this away from that. I get 24. But then this is in inches. Oh no, it's in. Yes, it is in inches. And then what do I do? So I've taken away the values. Then I'm stuck. So that's why I was not able to make progress on the problem, at least from my side. But that's something. So that's how you approach it. It's a wild problem, probably because it's concerned with trees, but also due to its wild nature. And there's also this question which you can try out. This is a nice problem. I think it is nice. If you just write down stuff the right way, then you should be able to solve it. So Jeremy starts with the X dollars. Has anyone cracked it? Ali, do you have any guesses?
I need to be more interested.
25%. Okay, maybe I'll wait this time. I'll wait until somebody cracks it, maybe.
It will be double here, so, the end will be, like, in 2002, it will be 2x. In 2003, it will be 4x. And,
So like this, right?
yeah,
Yeah. So this is times 2x times 2, get 4x, and then
8x. And 10x. Comparatively, 8.
you said how many x's in 2005?
10.
10.
Hmm.
16. So 16x is 480. Then what is x? 30, yes. That's a nice problem. And if you think about it this way, it's also even nicer.
There's a better way to write that as like an equation though, isn't there? I'm
Yeah, I mean,
trying to figure out how to do that, but I wasn't really sure. Could you do that?
Yeah, definitely. Yeah, and thank you for asking. If you want to write this immediately, you need to count the number of times it will double.
Yeah.
So from 2001, 2002, 2002, 2003, 2003, 2004, and then in 4 to 5. So it will double 4 times. So it will double 2. It's 2 times 2 times 2 times 2 times your initial investment will give you $480. Or you could, if you want to write more compactly, of course, 2 to the 4th of x to $480. We've also talked about this when we talked about growth and decay. So you start with an initial value of x, and your growth rate is 2, and the time periods are 4. So that's also another way to think about it. And if you just divide 480 by 2 to the 4th, which is 16, then you're good.
What's the level for the question?
It's supposed to be hard. What do you think? You think it's fairly set?
It's in the middle.
It's in the middle, right? Yeah, I was surprised as well. Now this is really one of my favorites. Looks hard, right?
2 minutes only.
Taking a lot of, like, confusing stuff. To get.
Exactly.
Getting,
Exactly.
like, reading all of it.
Exactly. So if you look at a question and you see that it has like a lot of info, then you probably shouldn't be reading all the info. So probably the first thing you need to do is to skip the table and read this as fast as you can. You want, or you can guess. 25%. But statistically, if you guess all the questions in the SAT, you have a very low chance of getting a good grade. We can talk about it maybe after. Like it's statistically it's so low, like you won't imagine how improbable it is to guess 4 questions correctly. Still, we'll take a look at it. Some interesting maths. That's the problem. I hope you can still see the problem. So I'll just read it very quickly. So distribution by location and power capacity of the 20 largest wind projects. Okay. The total power capacity of the 9 projects in Texas is 4952. Okay. The total power capacity of the 20 wind projects is 11,037. So 20 wind projects, 11,000. And 9 wind projects in Texas is 4952. Okay, that's some stuff. Now the amount of what energy produced in 1 hour at a rate of 1 megawatt is 1 megawatt hour. Okay. Now if each of the 9 Texas wind projects, so 9 Texas projects and 9 Texas projects again, had operated continuously for 24 hours at the maximum rate, then how many megawatt hours of energy would they have produced? Now, as I mentioned to you, you don't need the table at all. The answer is right here. So what do we need to find? It's the first question you should ask yourself.
Gigawatt hour energy. The 9 project megawatt hours.
So you need to find the total energy in the 24 hours, right? To find the total energy of 24 hours of which projects? The 9 Texas projects. Now, what do we know about the 9 Texas projects from what we have here? Just from the text.
1 hour is
That's just, yeah, so that's just that's just a general fact. But if you go a little bit upwards, you'll find some stuff about the 9 wind projects. So what's the power capacity of the 9 wind projects?
It's 950.
Okay. So that so this megawatt, this is the maximum capacity, right? This is the maximum it can go at, and we're looking to find the maximum rate of power. Then probably this is the maximum rate of power, but in how many hours? Just 1. 1 hour gives us 4952 megawatts. Let's call it megawatt hour. Okay, and we want to find the total of the 9 projects in 24 hours. Then probably we should multiply this by 24 hours. Do this. I mean, you don't need to use the calculator. I mean, just multiply by 24, you'll get 120,000. You get 118. But the idea is, even if you don't know this, and even if you don't know how to interpret this problem, you just focus on 24 hours at maximum speed, and you just look at these numbers, then probably the maximum rate for 24 hours is not 11,000, it's not 5,000, and it's definitely not 200. And then you can solve it. That's if, let's say, yeah, like if you have like 3 seconds for the question, then probably a good strategy. So that's something. I hope that wasn't too much. So the megawatt hour is the amount of energy produced in 1 hour and read 1 megawatt. The Texas projects produce 4,952 megawatts. Then in 1 hour, they produce 4,952 megawatt hours. Then in 24 hours, they produce 4,952 times 24 megawatt hours per, not per, megawatt hour. I lost it. I don't even know what I'm saying at this point. We should move on to the next question. So this is nicer. This is more friendly. We can be friends. Hi. I'm Omar. I'm talking to the problem.
Okay.
Just getting to know each other.
Ask something.
Go for it.
4A over 4A over B over 4A is equal 6.5 and the A
0.7.
6.7 and B over A is equal to 26.8. So it's actually the value of n. It's bigger than it's bigger than both the B and A, right? Maybe.
I don't even know what the values of A and B are.
So I guess
What do we need to find?
we need to find the value. We need to find the value of n and n.
So we want n to be equal to something.
Yeah.
Okay, do we have an equation which has n? Where is it? Is it this one or that one? This one or that one?
This one.
This one.
This one.
This one.
Yeah.
This one. Okay, good. So it's this one. Okay, can you solve for n? If I solve for n, from this equation, can you write n is equal to something?
Yeah.
What is this something? So if I multiply,
We need to do something first. For 4A over B, we need to solve this one before we go.
no, forget about 4a over b.
This is the structure, I guess.
No, forget about it. So you want to find n,
Yeah.
right? We're gonna do the problem downwards up. We're gonna start from the end point. We want to find n. That's our end goal. A over b n is equal to 26.8. You have an equation which has n in it, right?
Yeah.
Then probably if you solve this equation for n, we will get somewhere. Maybe we'll get the answer, maybe not, but we'll get somewhere. So let's do that. So can you solve for n? Can you isolate n from everything else in here?
Actually, but I guess that's that the n is equal like.
So maybe you can multiply both sides by n.
Yes.
Then what do we get? A
For B,
over
Over
b.
n. A over B.
Yeah. So the n cancels.
Thousand, so AN over BN.
But the ends cancel out.
Yeah, it's in this cancel. It's times.
Yeah, so the ends cancel out. This is on top. This is in the bottom.
NB.
Yeah,
So NB is equal to 26.8
times what?
times n.
Times n, because we multiply by n on both sides.
Yeah.
Okay, then from here, can you isolate n?
It's equal.
So you need to
Yeah,
multiply
but
by the inverse of 26.8.
It's 6.8.
right?
Yeah.
So you divide by 26.8, you multiply by the inverse, and so you get just n. So it's a over b times 1 over 26.8. Okay. Okay, so that's n, but that's not a number. It's not a number.
So
It's something. I don't know. So I cannot do anything with this just yet. Cannot do anything with this just yet. But then remember now that there is one fact which I still have not utilized, and that is take a look at it. Which fact have I not utilized yet?
6.74 A over B.
Exactly. So here I write 4a over b is equal to 6.7. Now give this expression a really good look. Here we have a number, right? But here we have a over b. That's annoying. It's annoying. We don't want it.
So we 4A times 8 and
So we need to replace this a over b with a number.
yeah.
Now, can we use this equation to replace this a over b with a number?
I guess so.
Okay, and how can we do that?
Take the A and B times 4A and 4A over B.
So we have 4a over b. Then how do I get something that says a over b? Yes. So if you multiply by 1/4, what do we get? A over b on one side, but what do we get on the other side? So 1/4 on one side cancels out. And on the other side, we have
2.7.
divided by, take your time. Yeah. Okay, then that's amazing. So we have something that we can replace this a over b with.
So 6.7 over 4 times 1.
Exactly.
26.8. So we times the like 26 times.
Just use the calculator, you know? Don't think about it. This looks horrible already. 6.7 divided by 4 times 1 over 26.8. So I solved the problem without even needing to use, just not needing to compute anything at all. I leave the computation to the very last step. So 0.0625, which I think you can also write as a fraction to as follows. Oops. No, that's not how you do it. These were. How do you write this? 1/16. 1/16. So you can. So if you're on the exam, you would write this. So that's also important for you. You won't write 1/16. You would write 1/16. Or you could also write the numerical answer. I think it will be accepted if you do it. But that's generally how you approach it. So here, this also has something to do with units. So a over b is something that's weird. We don't know anything about, but we don't need to know anything about it. You start from the end. You isolate your n. You have n is equal to 1/26.8 times something. So you try to find this something, and then you reach your solution. So that's all I wanted to say for today. Thank you very much for joining me, and I hope to see you next Monday. I will be uploading all of the worksheets. So for the remaining skills that we have, by Monday you will find all of the remaining worksheets. This should give you enough time to work on the worksheets yourself on Moodle, and you can always reach out to me with questions if you have it. And I'll stay here if you have questions. So maybe it's not a good time to start recording.